So with that overview of the kind of story of compost in mind, we'll run through each of the steps that I showed in the flow chart in this video. So first, inspecting and preparing the feedstock. We're removing contamination. We're grinding and shredding because we want to get that surface area for our microbes to work on. We might be sorting out, we've got leaf and yard waste coming out on one truck, SSO coming in on another truck, industrial waste coming out on another truck. We want to make sure that we're making the right recipe to target the right moisture, nutrient, pH, and free airspace in our pile. We might need to add water if we're really dry. We might need to have bulking agents if we're not dry enough. We're going to add some compost from the back end of our process to kickstart all those micros happening, and we're going to make sure it's nice and homogeneous. In the table on the right, you can see the different carbon to nitrogen ratios of different materials. And if you think about our target as 25 or 30 to 1, none of these are at that. They're either above or below. So it's important to have the right recipe in there to hit our nutrient balance. And similar story for our other parameters of interest, like moisture. We want to blend them together to get something that the microbes are going to be happy with in the next stage. Once we've got a blend we're happy with, this is our active composting. So that's that phase where our bacteria spike, our temperature goes really high, and our oxygen use is really, really high. So this is going to happen in our composting reactor, and we'll go through the different types of reactor. This stage can take a few days to a few months. It all depends on the system, where it is, what kind of material is going into it. In the first week, the bacteria are going to start growing really, really fast, and it's important to maintain our oxygen at about 13 to 18% to make sure that they have enough oxygen to work with. If we can't maintain the oxygen, our pile is going to start going anaerobic, and we're going to start producing biogas and odor compounds, and it's not going to be compost anymore. So really important to have enough air in there, and that's accomplished through designing a pile to aerate itself or applying active aeration, and I'll show you that in a few slides. We've got our heat generation, 55 to 65 degrees in here, and our bacterial population is going to shift as we modulate the temperature over the process. So we're going to have thermophilic bacteria at that stage where it's operating really, really hot, and then as we move into curing in the next stage, they're not going to be able to work as well as the mesophiles and the thermophiles as the pile cools down. So in the active composting stage, as I said, we really want to make sure we're getting enough air in. We're getting good surface area between all our organics and microbes in the air so we can have that compost reaction going to completion. And there's two approaches to doing that, active aeration and passive aeration. So in passive aeration, which is the picture on the left, we're allowing the natural gradients to move new air in and take the old air out. We're not putting any energy, we're just making sure our pile is structured so there's enough room for the air to get in, and it's going to diffuse in and do the job it needs to do. With active aeration, we're saying, well, that's not going to be fast enough. We have to give it a little bit of help. We want to add some air in. And there's two ways we can do that. One is positive aeration. So we're blowing air into the bottom of the pile and it's following the pressure gradient out of the pile. And as it's doing that, it's going and finding all those free air spaces and pushing in nice new oxygen for those microbes to use. And then we've got kind of the process air coming out of the surface of the pile. The other way we can do it is negative aeration. So instead of putting the fresh air into the bottom of the pile, we're going to put suction in the bottom of the pile, and it's going to draw the fresh air into the top of the pile. Now, one advantage of doing the negative aeration is instead of pushing all the air into the world and pushing all the odor with it, we're pulling it in, and we've got all our odor in one pipe that we can easily send to an odor treatment system. Positive aeration, we would need to collect it on the other side or have it inside a building to collect that odor. So negative aeration is kind of nicer for that, for getting our odorous air in one place, but it's also, because it's applying that vacuum, it can actually decrease the volume of the pile and close up some of that free air space by putting negative pressure in all those pores. So you need to make sure you have enough bulking agents to be able to do negative aeration. Otherwise, our pile is just going to go anaerobic because we're closing off pores even though we're applying this aeration to it. And odor control for compost is really, really important. And the reason that is more important for compost than AD is because we are actually using air as one of our process inputs, and we're going to have all this odorous air and the CO2 produced by composting as our output. In AD, we're not really using air at all. We've sealed it off and we're just producing biogas inside a closed reactor. We're still going to have odor from our receiving operations and our back-end operations, but the process itself is self-contained. In composting, our process is inherently producing a lot of air that's been through the composting process, and we have to do something with it. So I've got a whole nother lecture just on odor, but I just want to highlight that as we're talking about the composting stage, all this air coming through and coming out with odor is something we're going to have to worry about later. And there's an article on the screen here just talking about a digester that had to shut down because of odor complaints. There's been lots of digesters and composters that have had to shut down because of odor complaints. So this is a really big concern for keeping a plant running. Coming back to our active composting, so temperature is another important change happening through this phase. As we showed, the temperature is going to go up above 55 to 65 degrees Celsius throughout the process. And you can imagine that the middle of the pile is going to be hotter than the edges. The edges are going to cool off, especially if it's cold out. So there's rules usually in different jurisdictions for turning the pile every so many days so that each piece of waste is exposed to that high temperature for a sufficient amount of time. So typically regulations will say you need to maintain 55 degrees Celsius for around 15 days, and you need to turn the pile 5 times through that or something to that effect. Now, if the pile gets too hot, you can actually start killing off your beneficial microbes. So even though heat is good, there can be too much. So you want to kind of control how much heat is being produced. And the heat is being produced by the composting process itself. So if you slow down the composting, you slow down the heat production. So the way you do that, kind of your gas pedal for this, is your aeration. So if your pile is getting too hot, if you ease off the aeration, now the microbes are going to be limited by oxygen and they're not going to put out as much heat and heat the pile as much. So it's important in these processes to monitor the temperature and adjust the process so that it's at the right range the whole time throughout. And while the pile is heating up, this is when a lot of the water is going to be driven off as water vapor. And the term for this drying effect is called bio-drying. So drying actually takes a lot of energy. Like if you look at your household electricity bill, when you use the dryer, it's going to use a lot of energy because we need to apply that latent heat of water to vaporize it and things like that. So this is actually a key value of composting, is we're able to do this drying just using the energy of the process itself. With AD, we had this dewatering and we had to press it or centrifuge it, and then we had to deal with the water on the other side, maybe build a wastewater treatment plant. In composting, it's actually dewatering itself by heating itself up and driving off clean water vapor, and then all the solids stay there in the pile where they can be used and spread on the land later where they can actually be useful. So instead of destroying them in a wastewater plant, we're retaining them in the pile and sending them back to the land later on. Moisture is also a parameter that's changing throughout our process. So as all that bio-drying is happening, the moisture in the pile is going down. In our indoor systems, we can have a little bit more wet moisture because we have better odor and leachate control. Outdoor, we need to be a little bit drier so that we can control those better. Now, if we have too much moisture, as I mentioned, our pile will go anaerobic and we'll start maybe seeping some leachate onto the ground, which is bad. So we don't want to exceed the field capacity of our material. If it's too low, then the microbes are going to be limited by water and our composting isn't going to proceed well. To adjust moisture, water can be added at the beginning, but it can't be taken out. So we need to have dry enough material to target it at the right level as it goes in, which is why we might add leaf and yard waste, wood chips, shredded paper, things like that to make sure that our moisture is good going in. And then as it goes through the process, it just goes down and down and down. And by the end, we have a nice material like 45% moisture that's dry enough to, shovel and spread without having to worry about leachate and odor and things like that. Some more variables through our active composting phase is our pH. So we talked about wanting a neutral material coming in, and during the active composting phase, where all our bacteria is really spiking, we might see a little bit of a pH dip where all those bacteria are doing their work, but more microbes are going to follow them and be able to use some of their acid products. So that will bring it back into neutral. So there's not too much you can do once the process starts in terms of changing the pH. You just need to make sure it's in the right range going in. If you go too high or too low, you're going to start inhibiting the process. When you have a really basic pH, you'll produce a lot of ammonia, which is going to change your nutrient balance and is going to produce an odor from the ammonia. Where you get too acidic, you might start leaching metals out of the pile in your leachate, which is also not good to do.